Well, good morning, everybody. It's very early in the morning. I did last night on Fast Tracks Wednesday, which is a reminder to folks that if you are a Fast Tracks student or you are a subscriber over on fasttrackstube.com, which is going to be rapidly expanding in 2024. You've heard me say that. Well, it is, and I just want to do a follow-up of last night's training. First of all, we had quite a few students, or family members I like to call them, in our training last night. So that was awesome. I'm glad that you could join us. Remember, it is a bonus that you can utilize if you are a student or you are a subscriber on Fast Tracks Tube. You can join us on Wednesday nights. The links will become available to you if you're a subscriber. Or if you're a student, it's in your console. So if you're one of our Black or Plus students, then you'll see it in your console when you log in. Okay? All right, so great class last night. We talked Transformers, and I gave an awful lot of information in a short amount of time, right? In a little over 2 hours or so that we did it last night. And I kind of gave insight on Transformers and what you're probably going to see on an electrical exam. Now, we went over how to do turns ratio, voltage ratio, current ratio, how to do it if one is missing. If you have, for example, if they tell you the turns on the primary and the voltage on the primary, but they don't, and they tell you maybe the voltage on the secondary, but not the number of turns. We talked about the formulas that used to calculate that out. It's a visual thing, so I won't go into it here, but we talked about those basic formulas for that. And then we went into probably what you're going to actually see more or less on an exam is primary protection, secondary conductor protection when it's required, and all those kind of things. So, and more often than not, what we're going to have is less than 1,000 volt application. It's typically 1,000 volts or less. And we talked about the tables, which is, 450.3b is the table that we're going to be ultimately at when it comes to sizing the protection for the transformer. Now, the reason I brought that up last night, and I tried to give a bunch of little tips about it, is because it's really simple when you think about it. All we're doing with 450.3 and then B more specifically, all we're really doing is trying to protect the transformer. That's it. Now, that protection for that transformer, it just may be that protection, whether it's circuit breaker or fuse, depending on what you're working with, that protection may also protect the primary conductors. It may. And in some cases, that primary protection may also protect both the primary and secondary windings of a transformer, right? So when you're thinking about an exam, and 450.3b is broken down into, well, you've got a situation where typically for a transformer, we're going to be doing primary only protection. And so you can go up to 125% of the primary current, right? And you know how to do that, right? To get your current on a transformer, if you know the kVA, you just take the kVA, you divide it into, if it's 480 three-phase, then you want to make sure that you're doing the 480 times 1.732 if it's three-phase. If it's single-phase, you just use the face value. But as three-phase, you got to convert it. And most of you all know that 480 times 1.732 is 831.36, I believe, but you can just get away with 831. And then, of course, when you're doing the secondary, to find out what the current is on the secondary, it's the kVA, which doesn't change, divided by the 208 times the square root of 3, which most of you know is 360. Okay, so you can just use those numbers: 831 for 480. 360 for 208. Of course, it gets more defined into that in how you do it if you want to carry it all the way out. But reality is, that's how you size the current. Now, once you know the current, for that transformer, then that's when you're going to say, okay, now I have to protect the primary, and it may be that I can protect the secondary as well by primary only protection. Now, it tells us in 450.3b, okay, that if we don't exceed 125% on the primary protection, and remember we have a .1 there, so I mean it does allow us to go to the next standard size if it doesn't correspond. And that means if we were to go whatever the amps are on the primary at 125%, and then that doesn't magically match the same size breakers in the lists that we have in 240.6a, then we can just go to the next standard size, okay? Now, the theory behind that is, and I tried to get people to remember this by giving them an understanding that transformers have this inrush current that you have to take care of. It's kind of like this magnetic current that it comes when it starts up. And it's only going to last for a short period of time, but it's going to start up, and sometimes it can nuisance trip a primary protection. So you typically, in that scenario, are going to go to 125%. That is the maximum you can go to based on 450.3b, okay? And that would be primary only protection. And remember, we're just talking about protecting the transformer. That's it. We're not talking about anything else. Just the primary, just the transformer. So if that's the case, then if you don't exceed the 125%, except for the note that allows you in note 1 to go to the next standard size, then that transformer, primary and secondary, is considered protected, right? Clearly that overcurrent protection is going to be able to protect that entire transformer, let's just say it that way, as far as the protection aspect of it. Now, we also went over the fact that you have an allowance for up to 250%, right? And again, we're talking amps that are over 9 amps. So these are just the normal work that we do when it comes to normal transformers. We're not working with a small transformer here, although, again, it's not a complicated table to figure out where you're at in it. But in this case, we do have a maximum allowance that we can, and be careful on an exam because they might want to know what the maximum size is. Okay, well, if we run into that, then the maximum size is going to be up to 250%. Now, what's interesting with this one is that it's going to require that the transformer has both primary and secondary protection to be able to go up to 250%. Now, that's not something we're going to do just arbitrarily. Why would an engineer do that? Well, it could be that that feeder that's coming out of that transformer is actually, those secondary conductors are actually supplying more than one transformer. And so the combined inrush could cause a problem. So you're allowed to go up to 250%. Now, for us on an exam, we just have to remember that if they ask us what the maximum is, then we can use that 250%. But we have to have both primary and secondary protection for that transformer. Now, where could that primary protection is going to be? Anywhere upstream, right, of the transformer, or even at the transformer. But the secondary protection, this is where people get confused. It can actually be at the transformer, or it could be utilizing the same protection for the secondary conductors, and the protection is built into the, say, a panel board that we're feeding that has a main breaker. So literally that secondary protection, if sized properly, could be in the panel that you're supplying on the secondary. And so it's not only serving as protection for that for that panel board, but if sized properly, it's also serving as the required secondary protection for that transformer. All right? And so when you're sizing all this, you take that into consideration. So now there is a note 2 to that secondary protection, and that's saying, okay, well, we will also allow you to feed up to 6 breakers grouped in the same location. You can do that, or 1 breaker, it's fine. And if you have the up to 6, then the summation of those breakers can't exceed what it would be if it was a single breaker, if you were using a single breaker, okay? So, again, you just add up the breakers, that type of scenario. So that's one of those allowances that would allow you to feed the panel that's got like 6 big breakers in it from a transformer. Remember, you can't do that for a service, but you're able to do that for the transformer based on that rule, that type of scenario. Okay? Anyway, that's probably for another lesson. But so now, when it comes to the secondary, one of the rules that we have in 240.21c, this is secondary conductors now, that's coming from the transformer. One of the rules is you can't use the next size up rule in 240.4b. Now, we're all familiar with that, right? That's where if you have an amp on a conductor and it doesn't correspond with the overcurrent device, then you can go up to the next standard size and it's still considered protected as long as you don't exceed 800 amps, as long as you're not supplying a branch circuit with multiple receptacle loads, that type of scenario, and if it doesn't correspond, those type of scenarios. Then that's where you get the allowance to go to the next size up. Well, that does not work with secondary conductors, okay, from a transformer. It tells us specifically in 450.3b that we can't do that, right? So since we can't do that, let me give you an example. So let's say that I have a 400 amp overcurrent protective device that I'm supplying from a transformer, okay? And I want to supply it with a 500 kc mill, copper. Well, a 500 kc mill is only good for 380 amps. So since I can't use the next size up and protect it with the 400, right? The code says that I can't do that. I can't terminate it on a device like that. So what do I got to do? I would have to increase the size of those secondary conductors in order to match. Now, under the 10-foot tap rule, or 10-foot secondary conductor rule, I should say, more accurately, you have these processes that you have to follow, right? So the minimum size, which some people get on an exam, what's the minimum size secondary conductors? Okay, this is just a code rule. So the minimum size is telling us, it's reminding us that those conductors can't be less than the primary to secondary voltage ratio. Means you take the primary and divide it into secondary current. It's going to give you a value. Like if it's 480 and 208, then that's going to be a ratio of 2.31, right? Times the 1/10 the primary protection, right? So it'd be 1/10 the primary protection. So whatever you calculated out the primary protection, it's a 1/10 of that times the voltage, the primary to secondary voltage ratio, which is 2.31, okay? And so the conductor at that point cannot be less than that, right? So that's what that means. So that's a minimum conductor size, right? But the maximum is, we know, there really isn't a maximum. It's still, if it's supplying an overcurrent protected device, then you still have the rules that are in 240.21c2 that's going to tell us that we have to protect the conductors, and they're going to terminate into the overcurrent protected device. So it has to be protected. Okay. So all those rules you have to take into consideration, right? And so in consideration of those, we have to make sure that we size conductors accordingly. And so you can't use the next size up rule for that. All right. So anyway, we went over that last night. So hopefully the students got that. Now we'll remind you, if you're listening and you are a fast track student, then you can go over to the Sparky Hub, which you can get to now from the, and sorry for I'm driving. So again, not now, I'm parked, but you can go over to the Sparky Hub, and then you log in. If you're a Fast Track student and you have access to the Fast Tracks folder, in there I have some kind of tips from last night from the training, and then we have 6 or 7 videos that come from our Transformer series. That Transformer series is still available over on YouTube, and to be honest with you, I totally forgot, and it was supposed to be moved over to Fast Track's Tube, and it has not moved yet. So if you're listening to this and you haven't, and we haven't moved it yet, make sure you go to our YouTube channel. It's youtube.com/Master the NEC. And make sure that you go in there and go to our page and do searching and search for transformers. I think they'll come up if you just do transformers. And you can watch that series, and it goes in a little more deeper than what I just kind of given you a synopsis here on the podcast, that type of thing. So the takeaways I did with students is remember the little formulas I gave you for turns ratio, voltage ratio, how to calculate out when they give you at least three of the things that would be necessary to solve that. And you do cross multiplication. We talked about that last night. Remember transformer, to find the kVA of a transformer. By the way, to find the VA of a transformer, it's pretty much no different. It's the volts, primary side volts, times the current, and that's going to give you the VA. So again, if it's three-phase, don't forget the 1.732 scenario that you've got to figure into that equation. What else? All those type of things. So, all right, I'm getting ready to go in and get on the private jet here to jet out. So I'm heading to Philly, folks. Got to go to Philly Quesos town, Rewires town, and I'll be back this evening. So anyway, folks, just wanted to holler at you, give you a quick synopsis of last night, and that's the reason why you should join us if you can join us. We love to have you join us. Okay? All right. So until next time, folks, stay safe. God bless. Have a blessed day, and we will catch you on the rebound. Take care.